Well, welcome everybody. I'm Alison from the Postgrad Association. We're very pleased to kick off this series. This is a series of four on statistics and SPSS. Today's an introduction. Big welcome to Megan Lee from Bond University. And I'll post a couple of links in the chat box to become a member of the Postgrads. And also the recording will go out to our YouTube channel, so I post that link as well. I still see people still popping in, so welcome everybody. Okay, thanks, Megan.
All right. And Alison, if you can just keep an eye on the chat, and if anyone has a question or a comment, I'll try and pop it up as well when
Yep, will do. Happy to do that.
Amazing. Well, welcome everybody. This is the first of 4 workshops that we have on statistics and SPSS. Before I get going into the content, I just wanted to have a little bit of chat about who I am, where I'm from, and a little bit about the SCPA. So I am a SEU alumni. I did my PhD at Southern Cross, finishing in June of 2022. During that time, I was a very active member of the Southern Cross Postgraduate Association. And to be honest, it was a bit of a saving grace for me. The members and my peers, going to the Praxis conference each year and being able to network with like-minded people who are all going through the same thing as I was with my PhD was really beneficial. And when I had rough patches during my PhD, the SCPA committee and staff were always there to help me out with things. And I think it's a really good association because they're not underneath the SEU umbrella. They're by themselves. So if something happens where you need an advocate for you that isn't involved in the uni, the SCPA is a really good place for that. They also have all these wonderful workshops and learning opportunities. So I highly recommend, if you haven't already, to join the SCPA. I still have ties with the SCPA. I'm still friends with everyone in the SCPA, despite the fact that I have moved on. I'm no longer at SCU. I'm now teaching at Bond. But yeah, friends for life, basically. So highly, highly recommend. I've been teaching at Bond now for 3 years. I teach in psychology. I have an expertise in statistics and research methods, both quantitative and qualitative. We have done workshops recently in the past few weeks on qualitative research. So if you would like to learn a little bit more about qualitative research methods and what is involved there is a recording to that on the SCPA YouTube channel. And 2-3 weeks ago, we also did one on developing Qualtrics surveys. So a little bit of what we are doing today basically continues on from what we learnt about Qualtrics. So I'll be starting with Qualtrics and getting your survey out of Qualtrics and into the SPSS program. And later on down the track in the other workshops that we're doing next week, we will be doing intermediate statistics and SPSS, where we delve more into the descriptive statistics. So analyzing your demographic variables and having a look at what your data set looks like or what the people in your data set look like. Then we will be moving on to inferential statistics, like the more simple ones, like correlation and looking at relationships between 2 variables. And t-test, where we look at the differences between the averages of 2 groups, potentially, if you're doing experimental design. And then we'll move on in the last 2 weeks to advanced statistics, where we'll look at regressions, which is the big brother of correlation. So moving on from just knowing what the relationship between 2 variables are into looking at, well, can we predict what is going to happen in one variable from the results of another variable? And I might actually get a little poll from the group today to see what other advanced statistics techniques would be beneficial. I can teach logistic regression, I can teach ANOVAs, I can teach factor analysis, which is sometimes useful in PhD and Masters of Research. Not so much for honours, but today we're going to be focusing in on getting your data out of your survey platform, getting it into SPSS, and how to clean that data so that you are ready and prepared to do your analyses, because there's quite a bit to do. And when you are learning about statistics, this is the part that doesn't get taught very often. Usually we jump straight into the analysis, forgetting that there's this whole setup of data cleaning that needs to be done. So that's what we're doing today. If you need to contact me at any time, feel free to email me at my Bond email. I'm happy to answer any questions after the workshops. And you can also find me on Instagram, X, and Facebook at Food Mood Doctor, and my website, foodmooddoctor.org, where I also have all of the SCPA workshop recordings as well, if you want to find those. All right, so let's get into a little bit about what we are covering today. So first of all, we will discuss the basics of research design. So we cannot really delve into data analysis without understanding the framework and the foundations of research methods to start with, particularly quantitative research methods. So we'll look at the most important things to know before you start analyzing your data, such as levels of measurement, so categorical variables, continuous variables, and how they're broken up, and why it's so important that you need to know how each of your variable is measured so that you are able to tell the statistical software program what to do. If you have the wrong level of measurement, the program will do the wrong thing. Then we're going to go into data cleaning, how to clean the data. And while we do that, I'm going to teach you how to create from your scales that you have asked in your survey, how to transform them into a variable that you can analyze. And in doing that, how to reverse code those questions that are negatively worded or positively worded. So that's what we'll be doing today. But before we get into it, I might get you to pop into the chat on a scale of 0 being no experience with statistics and SPSS, and 10 being I'm advanced and know everything about statistics and SPSS. Could you pop into the chat box from 0 to 10 what your experience is, just so I know kind of what level we're all at and where to pitch the information that we are looking at today. Katarina is asking for ANOVAs, so yes, I definitely can do that for you. Process would be good. Miranda wants everything. Well, if you come to all 4 of the workshops over the next 4 weeks, I will cover as much of everything in statistics as possible. Thanks, Miranda. So we've got some zeros, a 2, 7, 0, 5, 4. Yep. No experience, 0, 5, 3s, 2s, 4s. 5 with stats, 0 with SPSS, but no R. R is excellent. And that's kind of where universities are kind of moving towards, is looking at R, computer programming language, rather than SPSS. But because SCU is still working with the SPSS program, and that is the program that they provide for free, then this is why we will focus on SPSS today. R is cool though. 3, 5, 0 with SPSS. I've done advanced stats but want to brush up. Some have used Jamovi, that's good. Yep, Jamovi and JASP are similar programs to SPSS that are just freely available online. I teach them as well, and in the future workshops, I will do a little bit of a tutorial on JASP just to show you how it's similar The reason that JASP is good and Jamovi are good is because once you leave the uni, you can still use them because they're freely available, whereas SPSS, you'll lose your license once you leave SCU. All right, so we've got quite a range of experience from nothing up to some fairly experienced members of the team, and that's completely all right. I find even when I do really basic learning of stats that I always pick up something new. And I'm also going to teach as we go through the data cleaning process some of the tips and tricks that I learned during my PhD that really sped up the user interface of SPSS that I didn't know. And I was doing things quite manually sometimes that were a bit clunky. So I'll teach you some of the shortcuts today as well. So that will benefit those who have a little bit of experience in stats and SPSS as well. All right, well, let's get going then. So the first most important thing before we begin trying to analyze data is to understand what type of research method or research design we are using. Now, there are several. So we've got our experimental designs. Now, these are considered the gold standard of research, where you take a group and you apply an intervention to a group. You may also have a control to compare your intervention group with, or you could have, say, a pre-test, post-test experiment where you test someone's, say, depressive symptoms before you apply an intervention, like, say, healthy diet, and then you test the depressive symptoms again post the experiment or the intervention. So there are experimental designs and they're considered the gold standard. However, it's not always possible or moral to do experimental designs. Now, a good example of this is in my field. So I'm the food mood doctor. My PhD and my ongoing research is in diet and mental health, particularly in dietary patterns and depressive symptoms. So how what we eat impacts our mood and our mental health. So for my type of research, it would be very immoral for me to take a bunch of, say, 50 primary school kids and give them McDonald's for breakfast, lunch, and dinner for 30 days, kind of like on Super Size Me with, yeah. So it would be immoral for me to do that. Ethics would never allow me to do that. So I can test whether ultra-processed foods like McDonald's are decreasing the mood or the mental health of the children. Would never be allowed to do that. So sometimes experimental designs are not possible. So quasi-experimental designs are really good for that. So quasi-experimental designs are designs that aren't quite intervention and control, but they are experimental in the way where your population is already experiencing that variable. So say we took a group of children who do already eat McDonald's for every meal, and we compare them to a group of children who do not, that can be considered a quasi-experimental design. Ethics will pass that because we are not putting those children at risk because they are already doing that behavior or experiencing that variable. Next is our descriptive designs. Now, descriptive designs are usually our qualitative research. So when I say qualitative, I mean focus groups, interviews, analysis of content on social media or through newspapers or historical documents. So descriptive designs are all about analyzing words and not numbers, whereas quantitative design, which is what we are focusing on in these workshops, are all about analyzing numbers. So the most common type of quantitative design, particularly for honors, PhD and masters, is our correlational designs, where you survey people using online survey or paper survey. You ask them questions about their behaviors or their demographics, and you see the relationships between the variables. Now, in my case, I do a lot of correlational design, where I send out surveys to people. I ask them about their diet, and I ask them about the way that they feel or their symptoms of depression. And then I look to see if there is a relationship between those two variables. However, correlational design is really good, and we can do a lot with correlational design, but there are some limitations to correlational design because it's usually only a snapshot of a cross-section of someone's life. The current correlational designs that I'm doing, I'm really interested in why people who eat a plant-based diet have higher depressive symptoms than the general population. When the diet they're actually eating, full of those rich plant foods, should be protective against depressive symptoms, but it doesn't seem to be the case. So a lot of my snapshots of these people in the surveys are people who are self-reporting as eating vegan or vegetarian diets at that point in time. But they may not have been eating that vegan or vegetarian diet the week before. They may not continue to eat that vegan and vegetarian diet the week after. So this is a big limitation of this type of design. We're only seeing what people are experiencing on that day when they do that survey. Better correlational designs are like longitudinal studies where we look at multiple time points. So say we take a survey of people who have a plant-based diet. We ask them every 3 months for 6 years. That's also a correlational design. We're still getting that snapshot of that one point in time, but we're seeing different time points across that person's life. So they're a little bit better. And sometimes you can see a little bit of cause and effect in longitudinal studies the same way that we do in experimental design because of that difference in time. And finally, our last research design is meta-analyses. Now, meta-analyses are where researchers take all of the research, say all of the experimental designed research on diet and depression, and they synthesize it all together. So they take all of the results from every single experiment that's ever been done on one topic, and they give an overall picture of what the outcome of that topic is. They can also do meta-analyses for correlational designs, and we can also do narrative reviews of descriptive designs as well. So qualitative research can be included in meta-analyses, not so much in the statistical portion of it though. Are there any questions about research design before we move on? Let's have a look.
Megan, I'm Shastri here.
Sure.
Is correlation design is qualitative?
Say that again, sorry?
Correlational design, is it qualitative?
No, it's quantitative. But in correlational design, you can ask qualitative questions. So the quantitative questions are your closed questions like, what is your age? And you give your age. Or what is your income level? And you have, say, 5 different levels of income that you can choose. Another question could be, on a scale of 1 to 10, how satisfied are you with your body image? And you give a number. Underneath that question, we could ask, why did you answer this question? Or could you provide more details? And the open-ended question or open-ended answer underneath that would then be considered a qualitative question. So correlational designs, research designs like surveys, can actually have a mix of both methods within them. So that's a very good question.
Megan,
yeah.
Sorry, thought you were finished.
I have another question, Megan.
Sure.
Eating disorders patterns in different geography and demography, they can be all correlated in one graph.
In one survey, yes. Yes, you can put any type of variable in, and you'll see that today when we move on to the analyses. I'll have geographical location, gender, age, diet, quality, depressive symptoms, all that type of thing. Daniel,
Okay, thank you.
Good morning, Megan.
hello, how are you doing?
Yeah, I'm fine, thank you. And I just wondered if you have any comment on when you're designing your study, perhaps a quasi-experimental design about on effect size and statistical power and how many people you're going to need. It's really kind of pivotal when you're doing recruitment and starting out in your study, isn't it? Thank you.
Absolutely. Thank you, Daniel. You're absolutely right. Before you start your research design, before we even get to designing our survey and getting it into Qualtrics, it's really important that we understand how many people we need to recruit and what sample size we need and what effect size we're using. So there is a program called G-Power that we use, and they have a full manual on how to use it. I can do a workshop on G-Power and the importance of power and effect size and things like that. So if not, I can put a video up on my website, Daniel, that I give to my students when they're doing research methods and they're doing sample size. And there's also a really good website called Layered Statistics, where you type in your variables that you've got and it tells you what analysis you should use. So that's really cool. I actually might put that up in the chat, the link to that one. But yeah, super important. It's one of the things that you must do before you even start recruiting. So
yeah, thanks. If those resources would be helpful, and I, without talking too much, but I've got G-Power, but understanding what those terms actually are, effect size and power, and how they affect the outcomes it's a difficult topic to understand.
Yeah, I agree 100%.
Thank you.
No worries. Matthew, I'm doing mixed methods in my PhD with correlational designs, survey of first year, final year, early year graduates, and descriptive interviews, each of these cohort 25. Working on the pilot study publication, hence lots of stats in this series is valuable. Ah, amazing. Yeah, I did mixed methods in my PhD as well. I did longitudinal studies on Australian women's diet and depression, and then I did focus groups with people asking them about their food and mood. So I'm a pragmatic mixed methods researcher. I truly believe that you can't find out everything about a topic using quantitative or qualitative by themselves. So I'm a big fan of mixed. Correlational design can be rating and multiple choice questions and open-ended questions, like if you answered yes, then give an example. Yep, absolutely. Amazing. Cool. All right, let's move on. So the next most important thing. So the first most important thing is knowing what research method that you need to use or what research design. The next most important thing is ensuring that before you start your data analysis, that you have your research question, your hypotheses about that question, and you understand which of your variables is your dependent variable and your independent variable. Now, I didn't even follow my own advice. In honors psychology, I got my IV and my DV around the wrong way, which was really interesting. So very important. I would highly recommend getting a Post-it note, putting your research question on it and your hypotheses and sticking it somewhere near your computer so that when you go into the data analysis and you're cleaning data and you're looking through the demographics and looking at the variables, that you can keep coming back to your research question, because it's it's a problem in research where you start diving into the data and looking at all the fun and exciting things that are going on, and then starting to hypothesize after the fact. So, and looking at what is significant in your data set, you must always have that framed in your mind before you begin. So this is what we are going to do. So here are 2 research questions that we're going to be focusing in on today in our data analysis. What I would like you to do is in the chat box, put in what your research hypothesis is. So our research hypothesis is basically a statement that can be tested in which a specific imperial outcome is predicted. A research hypothesis is not a guess. It is a prediction that is informed by your theory and your research. So you read widely, you come up with a gap in the literature, you develop a research question that you're interested in, and then you hypothesize about what you think will happen. Now, there's 2 different types of hypotheses, directional and non-directional. Directional hypotheses will tell you, you will hypothesize about what direction you think the question will go in, and non-directional is where you do not say what the direction is. So, and there's a lot of contention out there in the research world about which is better. I am a bigger fan of non-directional hypotheses because I want to test both tails of a question. I don't want to just test one tail of a question. So let's see, in the chat box, can you put what your hypotheses would be for the research question? Is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? Okay, so Bridget, a plant-based diet will have a negative effect on depressive symptoms. Now that's good, Bridget, but you're missing a variable. Can anyone see what variables are missing from that? What's missing from that? The quality of the diet. Good. So, Miranda, a plant-based diet has a relationship between diet quality and depressive symptoms. Yeah, that's good. That's a non-directional hypothesis because we're basically saying we will find a relationship between diet quality and depressive symptoms in those who eat a plant-based diet. What about a directional hypothesis? Can anyone give me a directional hypothesis for that research question? Karen, poor plant-based diets may have a detrimental effect on individuals. Yeah. So plant-based dietary followers who eat a poor quality diet will have higher depressive symptoms. That's a directional hypothesis. You could also hypothesize the other direction. So a high quality plant-based diet could decrease depressive symptoms, right? Yeah. So Zach's got that. Higher diet quality is associated with lower depressive symptoms in those who consume a plant-based diet. Good. So if we went into our statistics with a directional hypothesis about 1 or 2 of those directions, we would only be able to measure that direction. And we may miss out if the direction was the other way. So this is why I'm a big fan of non-directional hypotheses, because we can test both directions. So for this example, my research hypothesis would be there is a relationship between diet quality and depressive symptoms in those who eat a plant-based diet. All right, good job, everybody. Can we try the second research question? Do vegans or vegetarians have higher rates of depressive symptoms? Daniel, people who eat plant-based diets are more likely to be depressed, but why? That is my overall question of my whole research. We still don't know. I think it's because, just quietly, my hypothesis is that because they care about other things external to themselves. animal welfare, environmental concerns. They're socially excluded because of their diets. And very interestingly, once I finish the workshop today, I'm driving all the way down to Lismore to meet with my collaborators. And we are going to be looking at focus groups that we did with vegan men. So we were doing that analysis today, a qualitative analysis.
How very interesting, Megan. Sounds really interesting.
It's going to be fun. Vegans have higher levels of depressive symptoms compared with vegetarians, Katarina. Yeah, good. Zach, vegans have higher rates of depressive symptoms compared to vegetarians. Oh, why are we all choosing vegans? That's interesting.
Is there any evidence that vegans or vegetarians suffer from mental health?
Yep. So, and this is what happened in my PhD. I did my PhD on diet patterns and depression overall in the general population. And when I finished my PhD, I could summarize my whole PhD in 3 words: eat more plants. That's what the evidence shows. The higher plant diversity that you have in your diet, the better your depressive symptoms. So then I started looking at the literature, and there's like 9 systematic reviews that say that plant-based dietary followers actually have lower mental health than the general population. And that is what I'm trying to do, find out why this is when they actually eat a diet that is beneficial. Good. Zach, I like meat. Cool. It could be due to B12 deficiency rather than mental health. Yeah, and that's something that we're also looking at. Is it because of the diet or is it because of other things? Cool. So we all had a look at directional hypotheses for that final question, but what do you think a non-directional hypothesis might be for that? Do vegans or vegetarians have higher rates of depressive symptoms? Yep. So there is a difference between vegans and vegetarian depressive symptoms, basically, is our non-directional hypothesis. Good. So very, very important to have those nice and firm in your mind before you go into the data and to be constantly referring back to your question and your hypotheses so that you're not inventing hypotheses and questions while you're doing your analysis in line with what's significantly found. So that's really, really important. The next most important thing, so the third most important thing, is identifying what is your independent and your dependent variable. So who can tell me what an independent variable is? Bridget, the variable you manipulate. Yes, that is true in experimental research. What about correlational designs like surveys? Are we manipulating the variable? No, that's right. So the independent variable is a factually correct terminology to use for experimental design, but not so much for your correlational survey designs. We call the independent variable your predictor variable in survey designs. Lots of people use them interchangeably. That's fine. But if you want to be right on with the terminology, independent variable is experimental and predictor variable is for surveys and correlational designs. Graham, the variable which impacts on the other variable. Yeah, that's exactly right. So it predicts what's going to happen in the outcome. So who can tell me what the dependent variable is? The thing being measured depends on the dependent variable, the effect of the IV. Exactly. So the dependent variable is also known as the outcome. So it's dependent on what happens with the independent variable. And it is the thing that we are measuring. Again, dependent variable is a terminology most commonly used for experimental design. When we are using the dependent variable for survey design, we usually call it the outcome. So the IV and DV become your predictor and your outcome in correlational design. The variable that is subject to change based on the status of the independent variable. Very good. Excellent. We're all over it. So we know what the IV and the DV are. So in our example, for our first hypothesis or our first research question, which is our IV? Is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? Which one is our predictor? Massim. Hi, Massim. Diet quality is indeed our predictor or our independent variable. Which is our dependent variable or our outcome variable? Not quite read, got it around the wrong way. Depressive symptoms are our outcome variable. Very good. What's our population? People who eat a plant-based diet. Good. Vegans and vegetarians. Perfect. Can anyone tell me what the intervention and the comparator are for the IV? So if the independent variable or the predictor variable is diet quality, what do you think that we're comparing?
Could you repeat, please, Ian?
If diet quality is our predictor variable, what are we comparing in diet quality? Levels of depression? Yeah. But inside that IV, we're comparing low versus high quality diet. So plant-based dietary followers who eat a low versus a high quality diet. That's kind of what's inside that independent variable. Right, what about for our second question? Do vegans or vegetarians have higher rates of depressive symptoms? What's our outcome variable first this time? What's our dependent variable or our outcome variable? Yep, depressive symptoms again. Very good. What's our independent variable or our predictor variable in this question? Diet, kind of. It's diet groups, isn't it? So our independent variable is diet groups, and the two categories within that independent variable are vegans and vegetarians. Good. So this is showing us why it's so very important before we start analyzing to have very clear in our mind our research question, our hypotheses, and which is our independent and our dependent variable. If you get them confused, your analysis will not work properly. From the very beginning of setting up your scales and cleaning your data. Now, the last thing that we need to have nice and firm in our mind are our levels of measurement, because we need to tell the SPSS software program what measurement each of our variables are. So very quickly, we have 4 levels of measurement. The first 2 are categorical variables, and the second 2 are continuous variables. Categorical variables are pretty easy. It's where you can force your variables into categories. Our continuous variables are where you take your variables and they can lie on a continuum from negative infinity all the way through 0 to infinity. So I always think of continuous variables as lying on a ruler. That helps me to visualize what the level of measurement is. So continuous variables are kind of like on a continuum on a ruler, and our 2 categorical variables are forced into categories. So the very first one of them is our nominal level of measurement, which is any variable that can be forced into a category that doesn't have any form of order. So the most common level of measurement that's nominal is gender. Male, female, non-binary, and other, and transgender. I think they're the 5 that are usually most commonly asked in surveys. Can anyone give me some other examples of nominal variables that are forced into categories? Ethnicity, good, yes.
Maybe postcode.
Postcode's good. Socioeconomic status is usually ascertained using postcode, so that's a good nominal one. Country of origin, age, yes, you can put age into categories, but sometimes it's wiser to use age as a continuous variable for various reasons. Yep, all good. So they're our most common nominal variables. What about our ordinal variables? Ordinal variables are the same. They are categorical, but they have an order. Think of like running in a race. Someone will come first, second, and third. The levels between first and second aren't the same as the difference between second and third, aren't the same difference between third and fourth, but they form an order. My most commonly used ordinal variable is pass, fail, credit, distinction, high distinction. I use it every day almost. So that's an order, right? But there is not the same distance between a pass and a fail as there is between a distinction and a high distinction. Who can give me some other examples of ordinal data?
Likert scale.
Yeah, Likert scales are really good. And the most interesting thing about Likert scale measurements is that when we get into data analysis, lots of researchers accidentally use them as interval scales, which is not correct. So yes, that's a big problem. So knowing this is very, very important.
When you get to it, Megan, and maybe it's not today, but I'd be interested in you talking about how to handle that level of data in systems like SPSS, and getting meaningful results.
Yeah, I'll show you that today. It's very, very simple. All you have to do is transform your ordinal Likert scales into an interval scale. And that's what we'll do today, and I'll show you how to do it. Good, good. The next is our 2 continuous variables. Interval level data has known equal intervals between each of the distances, basically, but does not have a true 0. Ratio data has a true 0. So a really good example of interval data, is temperature. So temperature is on a continuum between negative, whatever the lowest temperature is, to positive, whatever the highest temperature is, with a 0 in the middle. 0 temperature does not mean that there is no temperature at all. So that's what interval data is. It doesn't have a true 0. It can go underneath 0. There can be negative values of interval data. Ratio data is the same as interval. It's continuous on a continuum, but it has a true 0, which means that at 0, there is nothing. A really good example of ratio data is height. So you can be 1 centimeter, or you can be, whatever the tallest height is, but you can never be negative height or negative age or negative weight. So age, weight, and height are really good ratios, whereas interval is any variable on a continuum that can go below 0. And the way I remember this is because ratio has an O at the end of it, at the end of the word, and it is the one with the true 0. So it took me years to figure out the difference between interval and ratio in exams. So now that's how I remember it. Can anyone give me another example of an interval variable? Katarina's got a really good question. What variable is depression? So when we measure depression in our surveys, we will use a pre-validated scale like the Centre of Epidemiological Scales of Depression, which is a 20-question questionnaire with Likert scales from 0 to 3. So 0, 1, 2, and 3. So it's a 4 scale Likert scale. Each of the 20 questions the participants will answer depending on how they feel. And I'll show you the questions in a moment. And then what we do, once we get our scale into our SPSS software, we then change it from an ordinal Likert scale into an interval or a ratio. So scores range from 0 to 60 because it goes from 0 to 3 and there's 20 questions. So if one participant answered 3 for every single question, they would get a 60. If a participant answered 0 for every single of the 20 questions, they would get a 0. So it ranges from 0 to 60. So which one do you think? Is it interval or is it ratio? It seems to be ratio, doesn't it? Because it can't go below 0. Yes, Katarina.
I'm just wondering how, like potentially depression, I think still can go below 0 because if, like it's kind of in a sense can go into the good mood, you know, like if someone have got -50 on depression, let's say, so
Sure.
it's means they're in a really good mood.
Yeah, you're absolutely right. And it really depends on the scale that you're using. So if the scale itself can't go below 0, then it's really measuring positive mood. And then you would use that. You would use a different scale like the POMS that measures both positive and negative effect. And then you could do both, and then it would become like an interval, right?
Okay, so it means that basically we have to look on a scale that we're using to identify our variables.
Absolutely. Exactly. And that's why age can be nominal, ordinal, or interval, because if you ask age, the question, how old are you? And I say 43, that's a continuous variable. It's ratio because I can't be -1. But if you ask the question, how old are you? 10 to 18, 18 to 25, 25 to 35, 35 to 45, then it becomes a ordinal measurement. So it all depends on how you ask the question in your survey, which is a really good segue to this activity. So I don't want you to answer these questions. I want you to tell me what type of variable you think that they are. So let's go with number 1. What type of variable do you think number 1 is? Ordinal, yes, I gave a very good tip just then accidentally. What about if I asked, how many children do you have? And I let you nominate how many children you have in free text. Ratio, good. What about what is your race? And you say what culture you come from in that box. Good, nominal. What about how old are you? And I'll let you free text answer that. Ratio, better, good, good. What about if I asked you, what is the highest level of school you've completed? And then the answers are less than high school or equivalent, bachelor's, master's, PhD, or other. Interesting. Lots of different answers to this one. It is ordinal. Yeah, because they are categories, but they have an order to them. Yep, good. What about what is your age? 0 to 19, 20 to 39, 40 to 59, 60 to 79. Yeah. Ordinal's correct. What is your political affiliation? And I'll let you free text answer what your political affiliation is. Yep, I agree. Nominal. And what about that final one? Overall, the educator is effective in this subject. And you've got little faces. Yeah. Good. Yeah, I agree. Nice work, team. All right. We've got, I'm just going to go through quickly. Just wait. Yeah, I'll just go through really quickly about data cleaning and how to get your data from Qualtrics into Excel, because there's two different ways of cleaning data. Some researchers like to clean their data in Excel first and then upload to SPSS. Some, like me, prefer to clean their data directly from Qualtrics into SPSS. I just prefer that, but I know a lot of researchers who do like to do it in Excel. There's strengths and weaknesses of both ways. So really quickly, I'll show you Excel and then we'll go for a 5-minute break and then we'll come back and we'll get into the data cleaning and the transforming of data in SPSS. Right. So what we are going to be looking at is a data set that I collected this time last year in March. I was interested in, because of that cross-sectional limitation that I was talking about earlier, all of my previous research on plant-based diet and depression, we kind of figured out that we didn't really know how long these people had been vegan or vegetarian for, how long that they would stay vegan or vegetarian for. And when we were doing the food frequency questionnaires, many people who self-reported as being vegan or vegetarian actually clicked that they ate meat in certain parts of the food frequency questionnaire. So we were potentially not looking at vegan and vegetarian diet and depression. We were looking at low meat consumers because many of them were actually eating or consuming dairy and animal products, which is really interesting to find in itself. So to overcome this limitation, I wanted to look at populations of people who had been vegetarian for their entire life and would remain vegetarian for their entire life. And my friend at SCU Gurmeet, who has just finished her PhD as well, helped me to recruit some Indian Australians and some Indians from over in India who were in religions that had meat consumption was against the religion. So they had been vegetarians their entire life. And when we snowballed the survey out, we also got lots of people from other religions who were interested. So we had people from Hare Krishna religion, Jewish, we had Seventh-day Adventist, we had lots of people. And then we also had people out in the general population who had never eaten meat as well for other reasons other than religion. So we did this survey because it removed that limitation that we were having in our other surveys. And that's the survey that we're going to be looking at today. So quickly, I'm going to show you how to export from Qualtrics into Excel, and then we'll have our 5-minute break, and then we'll come back and we will look at SPSS. So I'm going to see if I can be really tricky and stop share. And get Qualtrics up. Will it allow me to do so? And then I'm going to share my Qualtrics, and you can tell me if you can see it. Thumbs up if you can see Qualtrics. Yep. All right.
Yes. Yep.
Okay. So the last workshop that we did, I went through developing a survey in Qualtrics. So if you want to go back and watch that recording, feel free to do so. This will pick up exactly where we left off from that workshop. So in our Qualtrics, we will look for our projects, and we want to find the Vegetarian for Life project, which is just down here. It's closed now, so we're no longer recruiting. Open your project. And that up here in data and analysis, we click on data and analysis. And then export and import. We want to export our data from our survey directly into Excel. Download. Save it to your computer. And then we should be able to open it. Now, can everyone see the Excel file? Or can you still see Qualtrics? That's okay. So your Excel should look like this. Now, don't panic. This is what I say to my students when they open their Excel or their SPSS. There's all this information in there that is not necessary. So the first kind of 6 columns will be when the participants started the survey, when they ended the survey, how much of the survey that they did. So this will be 100% because this participant did the whole survey, how long it took them. And most of this is really not necessary. I delete all of this before I start analyzing. Now, what we're going to do after our break, we'll go for 5 minutes. We'll come back at, say, 10:35. Give you time to go and get a coffee. And then we will step into cleaning the data in SPSS and all of the wonderful things that we can do in SPSS before we start analyzing our data.
What time are we resuming again? Sorry, Megan.
10:35.
Okay. I'll just
And in the meantime, I'll go and find that layered statistics and the G-Power stuff and put them in the chat.
Okay, great. Thank you.
Hey, Megan, I'm just trying to, I didn't realize that I needed to have an account set up. With this, so I'm just waiting for that confirmation email so I can set up Qualtrics.
I'm back. Thank you, Alison. Is everyone back? Just pop up a thumbs up in the chat box. Hi, Miranda. You're having trouble getting the Excel sheet up. Yep. So, are you trying to upload an Excel from your own Qualtrics?
I've never used this before, so as I said earlier, I didn't realize that I needed to have Qualtrics or anything like that. So I've just set up an account and everything, but where to go
Sure.
from here?
So potentially it will be better if you go back and watch the recording for the previous workshop where I stepped through setting up Qualtrics, getting a survey into Qualtrics, recruiting from Qualtrics and things like that. You won't need Qualtrics for the rest of the workshop. We'll basically be just looking at the data analysis in SPSS now, but I'm just showing. Beg your pardon, sorry?
So we're just watching you.
Yeah, and I'm just showing you how to get the data from the software, the Qualtrics software, into the SPSS program for data analysis.
Yeah. Okay. Thank you for.
No worries. Perfect. All right. So just quickly, I will now show you how to get your data into SPSS, and then we will go through each of the data cleaning stages, starting from the demographics. So here is the Qualtrics program, very similar to what we did with Excel. We click on data and analysis. We click on export our data from Qualtrics into SPSS, download, save it into your computer, and then you will open it in SPSS. Just double click on the download and it will automatically go into SPSS. Again, it's so much information. Don't panic. Janet had a really good question in the chat about, well, how do we know if these variables here are not useful or we can delete them? You will know that before you get to this stage. So this should all be part of your preparation for analysis. So you will know if you need to know when the participants started their survey, when they finished their survey, what date they did it on, things like that. I have never had to use that because it's never been part of my research design. I've never needed that information. So I will go in and I will remove all of that information so that it is not in the way. So that's all part of data cleaning. So this is SPSS. SPSS, you have two different windows. The data view window, which is this one that we're in at the moment, where each column is a variable or a question on our survey, and each row is each participant's answer on those questions.
Megan, before you head into SPSS, can I interrupt? So
Yes.
we've got a question from Bridget. How do we get access to SPSS? Now, it's available through our technology services, I believe.
Yep.
Yep.
Yes. So IT will help you upload that to your computer. And every year they will give you a relicensing. Now, can everyone see SPSS or are they still on Qualtrics?
Can I just comment there?
Yeah.
I think it has to be a Southern Cross University computer. I don't think it can be your private computer.
Absolutely. Yes, you are right, Daniel. It has to be a SCU licensed computer. So for those of you who have been given a laptop like PhD students, that you will be able to put it onto those. If not, if you're an honors student, you haven't got an SCU computer, you will need to use the ones that are on campus.
So available in the campus labs.
Yes, all of the computers in the computer labs have SPSS on them.
Not sure about online students, but you could talk to tech services, technical services. Yeah. Okay.
Which is why these other programs that I'll show you in the future workshops are so invaluable now, like JASP and Jamovi, because they are very much like the interface of SPSS. They're very similar, but they're free, downloadable off the internet, and you can take them with you once you leave at SCU. Now that's our data view, with each row is a participant's answer on each of the questions, and each column is a variable and all of the participants' answers on that one variable. Then we have our variable view tab down the bottom here. Now, this is where we manipulate our variables and we tell SPSS what our variables mean and what we want to do with them. So to begin with, all of these ones here up to question 1 are not valuable for my analysis. So I will click on the top one, hold shift and click on the bottom one, and I will clear those variables. Now, it's really, really, really important, and probably the most important thing that you'll ever do is that you save your raw SPSS data set, save as, to your computer before you start deleting things or manipulating things or transforming things. So I would save my very first one as SPSS Veg for Life raw data. Then I would save continuously as I went along, changing data, so that if I make a mistake in my data cleaning, I don't have to go all the way back to the beginning and do it all again. So I'll tell you as we go along where the spots are that are the best to stop and save and have various versions of your data set. I learned that the wrong way. So in this variable view, we are basically cleaning the variables and telling SPSS what we want each of the variables to mean. Now, in the data view, we then clean the data itself. As you can see, it looks really messy at the moment. There's missing values, there's misspelt things. So we're going to clean that all up. These variables here, this looks like height. Someone's put centimeters in. That needs to be cleaned. So this all needs to be cleaned up because SPSS does not like words so much in its continuous variables. So our first variable here is, have you consumed a plant-based diet, vegan or vegetarian, your whole entire adult life? Now, this question was a question that we used to include and exclude participants. We didn't want any participants who had not consumed a plant-based diet for their entire adult life. And so if we go into the data view and have a look at question 1, and we click at the top, right click, sort ascending, you will see we have 42 participants who clicked into the survey and didn't even answer the first question. So I'm going to delete these participants, and you must make sure when you do this that you note down somewhere that you deleted 42 participants who did not complete any of the survey, because that's going to become part of your participant characteristics in your write-up. So that's very, very important to note down. So shift, cut, and those 42 will be removed from the data set. Now, the second thing that we want to do in this question is we only want to keep participants who said yes. When they answered no, I haven't been a vegetarian my entire adult life, they got sent to the end of the survey, and we didn't complete any of the rest of the survey. So we will right click at the top, sort descending, and it will show us all the no's. So all the people who said no don't have any other information or any other variables because they got sent to the end of the survey. So if we click the top of 1 and we go down and we find out how many people were not in our inclusion criteria. So there was another 143 participants who weren't in our inclusion criteria. So we will delete or cut those out as well as part of our data cleaning process. So then you will also write down somewhere 143 participants acknowledged that they had not been vegetarian for life and were excluded from the data set. Now, we don't need this variable anymore because all we've got here now is all the people who were vegetarian for life. So we can go into the variable view and actually get rid of that question now. We don't need it in our data set. So the second thing that we're going to do is we are going to clean our demographic variables. So the first one we have here, and the label will always be the label that comes from the Qualtrics program. So what the question was in the Qualtrics program. Now we're going to change that because the label in SPSS actually is the label that will be presented underneath any figures or tables that you have. So you want that to represent what you want to see in your figures and tables once you create those. So this one is, what gender do you identify as? So we will just write gender. And then over here is the name of the variable. Now, SPSS only likes one-word variables, no spaces. So we will name that one gender as well. It's a numeric variable. I like to make all of my widths 8. And I'm just thinking if I've got any open-ended questions that are really long. I don't think I do. So what width is how wide your columns will be in your data view. So I would click on 8 and then I would right-click, copy, and then I will click and drag all my variables. So we have currently 132 variables, and I would paste 8. So that's a tip because I used to go through and manually do that. So that means that all of the widths of the columns will be 8. All of our decimals look like they're set at 0 decimal points. So that's important. If you have variables that need decimal places, you can increase or decrease that here to 2 decimal places. Not needed for this one. So gender, what type of variable is gender? I'm just having a look at the chats.
Nominal.
How much detail do you need to write up for your thesis? Okay, so it's really, really important. Anything that you do in your data set that could manipulate the way that the analysis comes out needs to be reported. So any variables that you delete, any participants in particular that you delete, any changes that you make in your data set that could influence the end result needs to be written up in your data analysis strategy in your report. So gender is a categorical variable. Is it nominal or ordinal? Nominal. Good, Janet. Excellent. So for all of our categorical variables, this values column, when you click on it, it will provide you with what we tell SPSS our values are. So for gender, we are nominating males as a 1 value, females as 2, transgender is 3, other is 4, and prefer not to answer is 5. So it's important to remember those because in a second we will have a look at why. The missing column is not important at all anymore. It used to be. It's not necessary. You don't need to use it. SPSS nominates missing variables itself automatically now. And then I would go and copy the 8 from the width column and put it into the columns one as well. This is just a personal preference for how I like to see my data set to look, but consistent, all 8s. And then I kind of like all of my variables to be center aligned. Again, that's a personal preference. It's not necessary. You don't have to, you can have them left aligned. I just like them centered. Now, the most important thing when you are cleaning your variable is to nominate what measure that variable is. SPSS usually gets it correct. Sometimes it doesn't. So for gender, has SPSS got the measure correct? No, so it's a scale, and you'll see next to the scale word is a ruler. That means that it's a continuous variable, either interval or ratio. So it's not correct. We would like to nominate gender to be nominal. And you'll see next to nominal, there are 3 categories: green, blue, and red. So that tells you that that's a nominal scale. And next to ordinal, you've got your green, blue, and red, but in an order like a graph. So they give you a little bit of a pictorial tip on which one is which. So we're going to make sure that gender is nominated as nominal. Then the next thing that we want to do is, once we have cleaned our variable, we want to go and clean the data inside that variable. So we will switch back to the data view. We will look at our gender variable. So now it's labeled gender, it's nominal, and we've got each of the participants and whether they're male, female, prefer not to say, transgender, non-binary. Now we can right click and sort ascending. Now you'll see here are some participants who have not nominated a gender. Some of them have nominated other variables, so we wouldn't remove them, but others just haven't completed any of the rest of the survey. So we would probably remove them, but we'll remove them at a bit of a later date when we're having a look at the outcome and the predictor variable. So next to the gender box is a free open text box that says, if other, please specify. So we just want to check in that box what we've got. So we will sort descending. It tells us that this participant is non-binary. So we can go in to the gender variable and change it to, yeah, so it is other. So what we might do here is, because we have a non-binary participant and they don't fit into any of our categories, is go back to the variable view, go into values, and add a value for non-binary. So we do 6, non-binary, okay, and that will add another category. And then we can go back to the data view, to the person who acknowledged that they were non-binary, and we could choose non-binary for them. The other person has written that they are vegetarian as their gender. So when something like this happens, and it does happen quite often where you have something that doesn't make sense, we would just leave it as other. Now this variable here, we've used the information from it, so we don't need it anymore. So we can now remove that other please specify variable. And then we have all of our genders in here. And that's our gender variable nice and clean. So we sort ascending, we can see that we have male, female, and then our transgender, other, and non-binary. Nice. So that's a categorical variable. Let's do a continuous variable. So this is age. Now here it says that the type of variable is a string variable. That means the variable is in words. Now that might be because someone in the age variable has written years somewhere. Yeah, see here, number 17 has written years. So we need to clean that up and change that to 65. Go down, make sure there's no other words in our age variable. There we go, 44. Change that so that it's a numeric. Has anyone else? Yeah, 35 going. Just say they're 35. 33 years, we need to change that. because SPSS won't analyze your variable if it's got words in it. And as you can see, height and weight have similar problems. So you would need to go through height and weight and change them as well. 2001, so this survey was done in 2023. So I'm assuming the person is 22 and has just said what year that they were born. So keeping in mind that you can make these calls, 1989, 2023 is I should be able to figure this out. Is it 33? 34? This one's saying that they're 13 years old. So that's a problem. Because our inclusion exclusion criteria was 18 years and over. And look, we've got a fair few 13 and 12-year-olds. That's weird and not great. So, whoops. I think that was a male. Let's go back. We've cleaned up the problem with the numerics. So we'll go back into
Megan,
Yes?
the previous one you changed to 34. That should be 19. You go up.
This one? This one here.
19. It should be 19.
Thanks.
Okay.
See, and making sure when you're cleaning your data that you don't make mistakes is very important because you could fudge your data. Right. So now we can change this variable type to numeric. Okay. We have 0 decimal places. We want to name or label it age. Now we don't have any values because it's a continuous variable, so we don't need to worry about that box. Missing columns, center aligned. Is this variable, what type of variable is this? Is it scale? Is it nominal or ordinal? Age. So it's a scale because it's a continuous variable. So we need to make sure that that is set out like that. Yes, Matthew?
You just said something there about it's okay to, go through and do this sort of cleaning because, like, you've got to be accurate with this, right? Like, otherwise you could, this is where fudgification can occur.
Mm-hmm. That's exactly right. So we need to be very careful as we go through that we do things precisely. But like Massim said, like these are ordered from in age order, and I put 34 here, so it was sticking out because it was actually 19. All right. So now that we have cleaned the age variable, we want to go in and make sure that everything is okay with our actual data. So we will right click, sort ascending. Again, you can see here heaps of people who have not completed any questions in there. So we will eventually delete those. But our age, we have a 12-year-old, 13-year-olds, some 16-year-olds. So we've got 1, 2, 3, 4, 5, 6, 7 participants who are under the age of the inclusion criteria. So we would delete those and you would write that in your participant characteristics. 7 participants were underneath the age of inclusion and were deleted from the data set. Then we would click and sort descending so we can have a look at our older participants. So oldest participants, 85, that's completely fine. That seems like a relevant age, so we would leave that. So that's a little bit of a brief tutorial in how to clean the demographic variables, our categorical and our continuous demographic variables. You'll notice we've got here height and weight, what country do you live in, marital status, education level, do you identify as vegan, semi-vegan, vegetarian, semi-vegetarian, lacto-vegetarian, ovo-vegetarian, pescatarian, flexitarian. Now, what we can do with this variable in particular is if we want to allow plant-based dietary followers to self-report the type of diet that they follow to be sensitive, but we're only really interested in people who are vegan or vegetarian, we can then create a new variable from this categorical variable that is just vegans and vegetarians. So if you have a look here in the categories, our vegans are values 1 and 2, and our vegetarians are values 3 to 9. Although, would we include flexitarians in our vegetarians because they eat meat, right? So this is where you have to make decisions about your data set and what you're going to do. Are you going to exclude the flexitarians from your data set completely because they consume meat? Or are you going to include them as part of the vegetarians? So to do this, to create this new variable, we will go up to transform recode into a different variable. Now, if you recode into the same variable, it will override the information in that variable, but we want to keep that in case we're interested in looking at all of those different types of vegetarianism and whether or not there's different levels of depression, right? So we want to recode into different variable. We're going to find the vegetarian variable here, which is question 9. We are going to rename our new variable vegan _ veg. And then we're going to label it vegan or vegetarian. Change the name of the variable. And then we're going to go into old and new values. And for any participant that has a value of 1, we're going to give them a value of 1. So we're going to call our vegans 1s. Participants who were 2, they were our semi-vegans. We're also going to call them a 1 because they were vegans. And then everyone else was some form of a vegetarian. So 3 we'll call 2 and we'll make 2 our vegetarians. Anyone who said 4 is a vegetarian. Anyone who was a 5 was also a vegetarian of some sort. 6 was a vegetarian. 7 was a vegetarian. 8 was a vegetarian. And then our flexitarians, we are going to nominate as vegetarian as well. Continue. Okay. Now that's going to create a brand new variable at the bottom of our list. And you can click and drag it up so it's near the other vegetarian variable. It doesn't need decimal places. Then we need to go into the values box and tell SPSS that any value that was a 1, we want to label as vegan, and any value that's a 2, we want to label as a vegetarian. And our scale of measurement is nominal, which is correct. So that's our brand new variable. So we can go in and have a look and clean our variable by sorting, ascending. Again, we've got all of that missing data there. But there's our vegans. Quite a few. And there's our vegetarians. So we had like 200 something vegans and 200 something vegetarians. So nice and even, which is quite good. So that's how you create a new variable. Excellent. Now, the next question, which is really important, is if I ask for my scales, for my independent and my dependent variables, so all of the things that we've done so far are demographic data. It tells us what our participants look like. We can, in the next workshop, we will take that data and we will look at how many vegans and vegetarians we had, what the average age of the participants are, what the gender split is between males and female percentage-wise. We'll look at marital status, how many single, how many married. We'll have a look at height and weight, and we will take height and weight and turn it into a BMI category. And we can change it to a continuous BMI as well. And we'll look at that just to tell us what our data set looks like. What do our participants look like before we answer our research question? The next step is to use inferential statistics to answer our research question. But to do that, we need to take the scales that we developed for depression and diet quality, and we need to turn them into a score that we can use to analyze the data. Now, what we have here for depression is 20 questions from here to here, asking questions about how the participants felt in the last week. And it is pre-validated, so it will tell us what their depressive symptoms are. Now, the values or the categories for each of the 20 questions, participants could answer 0, which is I rarely felt this, to 1, some or a little of the time, 2, occasionally or a moderate amount, or 6, most or all of the time. Now, there's a problem with this because the scale actually ranges from 0 to 3. So importing it from Qualtrics, Qualtrics has created for itself its own variable numbers. So we would have to go through and make sure that we change any variable in these ones here that are a 6 to a 3. And then we would have to change this to a 3 as well, the categories to a 3. But for ease of explanation, I will use the 6 as its variable number because that's what Qualtrics has given us, which is great. But that is a really, really important lesson that a lot of students don't realize, is that they go to, say I went and did all of this with the 0 to 6 variables, and I gave a continuous score for depression, it would be highly inflated compared to what the actual comparison of other research has used this variable, because they've used all 0 to 3. So it's very, very important that you go in and you check that Qualtrics hasn't just invented a value that isn't aligned with what the scale actually does. I wonder, I'm going to see if this works. So another tip and trick that you can use in SPSS is, see, question 11, number 1 is our first question for that CESD scale, but it's telling us what the category is. If you go up to this button here that says A/1 and click it, it'll give you the values of the categories rather than the names or the labels of the categories. And I'm wondering if I select all of the CESD scale from 1 to 20, can I change the 6s to 3s? Do you reckon Control H works in SPSS? Is the real question here. You know, in Word, how you can Control H things? Let's see. No. Oh. See, all the 6s need to be changed. So you'd have to do that manually, I'd assume. Anyway, We will continue with how to code and reverse code your questions. So there are 20 questions for our CESD. Now I'm just going to quickly flick back to the PowerPoint presentation so I can show you what the scale looks like. So this is the CESD. In scoring the CESD, you get a value from 0 to 3, 4 items, 1 to 3, 5 to 7, 9 to 11, 13 to 15, and 17 to 20. They're all positively scored. But if you have a look at items 4, 8, 12, and 16, they are negatively worded. So I was bothered by things that usually don't bother me. If you said rarely or none of the time, you'd get a 0. If you said most of the time, you'd get a 3. But question 4 is negatively worded or worded the other way. I felt that I was just as good as other people. Or number 8, I felt hopeful about the future. So these questions are reverse coded, and Qualtrics doesn't reverse code them itself. You have to do that inside of SPSS. So remembering that we've got 0, 1, 2, and 6 in our data set, we will reverse code 4, 8, 12, and 16. So we are going to, before we create a continuous score for each of our participants, I'm going to stop share. I'm going to reshare SPSS. So what we need to do is we need to go to transform, recode into different variables again. So remembering, don't override your current variables. We're going to reset what we have in there already. And we're going to go down to our list of CESD questions. We're going to right click and we're going to display the variable names because it's easier, because we want question 4, question 8, question 12, and question 16. 4, 8, 12, and 16. Yep. They're the ones that need to be reverse coded. So you click on question 4. Call it reverse coded. Question 4 reversed. Do this for each of the variables. Question 12 reversed, and then question 16 reversed. So we're just labeling these new variables, and they're going to create us a reverse coded one. So any value that's a 0, we want it to be a 6. Any value that's a 1, we want it to be a 2. Any value that's a 2, we want it to be a 1. And any value that's a 6, we want it to be a 0. And this will reverse code those 4 questions. So we will continue. Okay. And down the bottom of our data set are our 4 reverse coded questions. We'll drag them up so that they're at the top here. So that's a very, very important step that we need to do before we create a continuous variable for our participants. So that's the next step. Each participant needs 1 score for depressive symptoms, and currently we have 20 questions for each participant. Now, what's really easy is turning this Likert scale into an interval scale by creating a continuous variable. So to do that, we will just getting that slide up. Transform, compute variable. We're going to call the target variable depression or depressive symptoms, continuous. Then we want to scroll down to our list. Oh, there is a problem. Can you see here how the reverse coded questions have been selected as nominal and the others are all scale? That's a big problem. I'll just get out of that, go back to our variable view. So these are all Likert scales. Remember, the Likert scale is ordinal, so they should all be nominated as ordinal over here in the measurement. So let's click ordinal, copy that, and then just click and drag all of the variables that are nominal and paste. Otherwise, SPSS will not let us compute that variable. Until now. Right. Transform, compute variable, target variable, depression, continuous. Scroll down to our ordinal variables. Yay. And we just want to change, right click and display variable names and begin from question 1. So to get a participant's total score, we want their score from question 1 plus their score from question 2 plus their score from question 3 plus their reverse coded score from question 4. So make sure that you put the reverse coded ones in, not the old originals, plus 5 plus 6 plus 7 plus the reverse code for 8 plus 9 plus 10 plus 11 plus the reverse code of 12 plus 13 plus 14 plus 15 plus the reverse code of 16 plus 17 plus 18 plus 19 plus 20. And that's telling SPSS that we want to create a total continuous score for depression for each of our participants. We click OK. And in our data set all the way at the bottom, we have our continuous depression score. Bring it up the top with the rest of our stuff. And then we want to make sure that we clean that variable. So it's numeric. We might need, oh, I don't think we do actually, decimal places. Create a label, depression, total score, ranges from 0 to 60, which it won't because it's got 6s in it, but that's what it should be. Highest scores equal greater symptoms of depression. Now, the reason that I do this little explanation is because when I go to interpret my analysis later on, when we analyze the data, it makes it heaps easier for me to understand than having to go back to the paper and be like, oh, what did this variable mean? So I like to give myself a little bit of a heads up there. Because it's a continuous variable, we don't need to put categories in. And it is the correct level of measurement of scale. So then we go back to the data view. We have a look at our depression continuous. It should be between 0 and 60. It's not going to be. It's going to be between 0 and 6 times 2, 120. So you just want to sort ascending and make sure. So 0 is the lowest. That's perfect. And then sort descending. 76 is our highest. So that falls in that 120. But if you do this and you find that your scores are outside of the 0 to 60 in this case, you'd be like, oh, something's gone wrong. And this will give you an indication that Qualtrics had put those 6s in. And I probably wouldn't find it until this stage because that's how I roll. Right, good. So that's how to create a continuous variable for your scale. Now, it's usually at this stage where I would delete participants and save the data set at this stage. So this is a really good stage to save the clean data set with your demographics and then move on. So you can see here, this is how many people have not got. So there is another 91 participants who haven't answered the outcome variable. And that's really concerning, because if you do your data analysis with those 91 people in it, they're not going to be included anyway. And it looks like mostly they haven't answered most of the other questions either. So I would remove those 91 participants and report that, saying a further 92 participants were removed for not completing the outcome variable of depression. But that is a decision that you need to make with your team and your supervisors before you get to the data analysis stage. Are we going to remove participants who haven't completed, say, the diet quality screener and the depression scale? That's usually what I would do, because they're the two most important variables. So that leaves us with 328 participants in total. I think we started with something like, Qualtrics will tell me, 470 or something. So we got rid of a fair few participants, but that's quite normal.
Megan, there's a few interesting comments in the chat as we're kind of got a few minutes left.
Yeah. Okay. Is this unique to the specific instrument you are using, Megan, or generally accepted transformation? Yep. So the transformation that I just did with the CESD is what you usually will do. You'll need to go into the paper for the scale and figure out whether or not they use a total score like we did today, or an average score. So, and that will be the only difference. For those that are an average score, we would do exactly the same thing as we just did, and we would just divide it by 20. So the 20 questions that were in there. So it will just depend on what the scale and how other people have used the scale. So that's a really good question.
Very helpful. Thank you.
Can you sometimes use an average number in place of no answer? Okay, so that's a really good question about missing information. Now, if, say, the participant has just not answered one of the depression questions inside the depression scale, but has like 19 or 17 other ones, you can do a mean imputation, which means averaging the rest of their depression scores and putting it in. But if the person doesn't have any, or only 50% of the depression questions answered, then it's not wise to do so. Again, these are decisions that you would make before you do the analysis, so that you're not making decisions after the fact. So you'd get together with your team and say, okay, if we have participants who have 80%, have done 80% of the depression questions, we'll average out the rest and we'll do mean imputation. If not, the participant will be disincluded or excluded from the data set. So next time we come together next week, we will be doing the next step after this. So I'll have the data set completely cleaned, and we will start looking at descriptive and inferential statistics. But I'll also go back through the data and show you the CESD, how it's supposed to look, 0 to 3, and answer any other questions you have about data cleaning before we start kind of going into analyzing the descriptive statistics and things. So if you start working on SPSS in your own time in the next week and you have questions, feel free to write them down, and I'm happy to answer them at the beginning of the next workshop, and maybe going through maybe some of those data cleaning and transformations again, if you're interested.
Yeah, thanks, Megan. Very useful today. Look forward to next week's session.
Thank you so much. And if at any time you would like to revisit the recordings, they're all up there on my website. They're on the SCPA YouTube channel. All my research and stuff is up there too, if you're interested, including the paper Daniel and I have together.
Good to hear.
Excellent.
Thank you.
Thank you, everybody. I'll just answer
Excellent.
any more questions in here.
Yep.
What's the link? The link to my website is www.foodmooddoctor.org.
Okay, great. Thank you so much, everyone. See you next week, Thursday the 18th, I think it is.
Yes,
That's
thank you
right.
so much, Alison.
You're welcome. I'll stop recording that. Okay.